we're going to determine whether this series is convergent or divergent. So we have our series a sub n, and we want to take the absolute value of a sub n and find out if that's convergent or divergent. So the absolute value would be the absolute value of cosine of n pi over 3 over n factorial, which is the same thing as just taking the absolute value of the numerator, because n factorial is going to be positive anyway. And then, since we know that cosine of n pi over 3 has to be less than or equal to 1 and greater than or equal to negative 1, because we know this from the graph of cosine, which is always between negative 1 and 1 and includes 1 and negative 1, then we know that the absolute value of cosine of n pi over 3 has to be less than or equal to 1. Therefore, we can make a comparison. We can make a comparison in which this is less than or equal to the series, which has 1 in the numerator and n factorial in the denominator. Now we can find out what happens when we take the ratio test of our new series b sub n. So b sub n is going to be 1 over n factorial, and we're going to use the ratio test. So the ratio test is when we take the limit as n approaches infinity of the absolute value of b sub n plus 1 over b sub n. Then if this limit as n approaches infinity of the absolute value of b sub n over b sub n gives us 1, it's inconclusive. If it gives us something which is greater than 1, then it diverges. If it gives us something which is less than 1, then it absolutely converges. It absolutely converges, which implies that it also just converges. So we're going to do that. We're going to take the limit as n approaches infinity of the absolute value of b sub n plus 1 over b sub n. Limit as n approaches infinity of the absolute value of 1 over n plus 1 factorial over 1 over n factorial. We can rewrite this to multiply by the reciprocal, which would give us n factorial over n plus 1 factorial. Now we can notice that we can factor out an n factorial from this denominator. So this is the same as the limit as n approaches infinity of n factorial times n plus 1, and we have n factorial in the numerator. We can factor out n factorial because all that n factorial means is that you're taking whatever n is and you're multiplying by the previous integer, and then multiplying by the previous integer from that. You're just subtracting one integer and multiplying by that. So obviously, we could have n plus 1 times n factorial in that denominator. If you don't believe me, you can plug in values for n. Okay, so now we take the limit as n approaches infinity of that. We have to cancel this out because those cancel. We have 1 over n plus 1, and now we can plug in infinity into that denominator, just as it is, and we would get infinity plus 1, which is just infinity in the denominator, which is 0. 1 over infinity is 0. So we get 0, which is less than 1. Since it's less than 1, by the ratio test, it absolutely converges. This absolutely converges. Really, it's the entire series which absolutely converges. And since this is less than something which absolutely converges, this must also absolutely converge.